So we're in a cruise now, real weather, from Pisa to Cagliari. And we're gonna perform the VOR X-ray runway 32 in Cagliari. It's a short flight. This is considered to be a short flight. I've set up everything. Only close to 80 miles from the top of the descent. As you can see, we're at level 330. So I start the every briefing with a big picture of the threats. So, for example, in this case, we can introduce QNH blunder error. I already got the 80s, is 1023. We already cross-check it with the pilot monitoring 1023. That's blunder error. Also, the pilot monitoring will have the VSD. The QNH blunder error threat is mitigated. Another threat is an offset approach. So we have a high minima. High minima, as you can see, here is 900. When you have a high minima from 900 and above, we put the misapproach altitude. In this case, it's going to be 3,500 feet. We're going to put it at 300 feet above. So in this case, it's going to be 1,200 feet. Otherwise, there is the risk of an alt acquire. I wouldn't say there is any other particular threats for today. Then I introduced the aircraft status, the weather, and the NOTAMs. If this was an RMP, I would have also said included in the NOTAMs there is no RAIM outages, and I would just cross-check. 250 below 100, forecast page is loaded, and so on. Fixed rings, runway 32, 10 and 4, top of descent. There is not really an arrival. We can expect, in this case, in the simulator, I put Covas, then Carbonara, and then let's say Epida. I don't want you guys to lose too much time here in plan mode and check yourself point by point, step by step, because anyways, this will be done together later on. The only thing that you have to check is that you don't have any spaghetti line, as someone will call. So some donuts here, double entries, for example. I'm going to exaggerate it here. I'm going to put Covas after Carbonara. As you can see, it creates this. So if I execute it, you will see that there is something wrong basically on the arrival. So we don't want to see any of this. So I'll put back Epida below Carbonara, and that's the routine that we expect. So don't lose time, guys, by yourself here, checking step by step, but do check a big picture. So is this what we expect? Is this exactly on the plate? Then after you're done with that, of course, you will brief an arrival if there was one, and then you're gonna start reading the chart. So this will lead us for the chart 13-6, effective 13 September 24. Cagliari VOR frequency 13.4. 13.4 is set active. Final approach course is 313. 313 on both sides. The FAF is at 7 miles, 2,100 feet. The minima, we'll talk later. Airport elevation 11. MSA 6,100 to the northwest, 5,700 remaining sector. The altimeter set in hectopascal, transition altitude 6,000, TME is required. There is a Decimo Manno 6 miles north west of the airport. It's a warning. Highest point depicted in the chart is 3,920. If you can read me the distance versus altitude, they're in just below the chart, depicted here. And PAPI left and right, high intensity approach lighting system. The missed approach is going to be straight ahead, so we're going to go in this case to plan mode, and we check the missed approach, that the image and the coding of the missed approach is the same. So we proceed on final track 3,500 feet. 3,500 is on the next page, passing 2.5 miles from Cagliari. CAG 03, we turn right. This is a right turn here. Right turn here. To intercept and follow the radial 360, radial north, Cagliari 360. to Turud and hold at 3,500 feet. The hold at Turud will be 180 inbound with a right turn. So you go hold, 180 right turn, 5 miles. It will be flown Toga, go around flap 15, second on thrust, gear up with a positive rate and now plus 5, tune ready for a miss approach, flaps 1, up, I'm not ready, gauge the para decide what to do. After we talk about how we're going to fly the miss approach, we talk about the minima, set independently twice. You can say, I agree with you, if you see the same. If you see something else, something different in the minima, you can just say, what do you think the minima is? For example, I see something like this, and I ask you, what do you think the minima is? Just to wake you up, basically. I'm going to put it back to 840. And it's 840. RVR required is 2,400 meters. And that's it. So the chart briefing is completed. It's just like a normal ILS, basically. After you finish with that, you do the double briefing. I use the acronym FAIL. FAIL is for flaps and FAF. So basically, what I want to know is go to the plan mode, and we use our brain. So we go to plan mode, we go to Carbonara, we identify the diesel point. Unfortunately, in the simulator, in the plan mode is not depicted. I assume we're going to have a diesel point somewhere around here in the real aircraft. So leaving Carbonara, I want to have 220 knots. At the intercept, I want to have 180 knots. So flaps 1, flaps 5 with 180 knots at the intercept. Consequently, gear down flap 15 by the 4 miles, flaps 30 afterwards, probably gonna land. F also states for FAF, so we check on the chart. The FAF is at 7 DME from Cagliari VOR. 2 miles before that, that would be called in the ND. You're gonna call me the approach and descent. I'll say 900 set, VNAV path, speed intervent. We'll continue down the 3.03 on the plate, 3.03 here. MCP mode selection would be LNAV and VNAV. The intention becoming visual. Let's not say just randomly what are we going to do in case we see the runway. Of course we're going to disconnect. We know that we're going to disconnect and land. The question here is, are we going to keep the flight directors or not? Are we going to recycle them? In this case, we'll have to recycle the flight directors. Another important thing, as we discussed earlier, the minima is high. So we're going to set 900 set, VNAV path speed intervent at approach and descent. So when the minima is above 900 feet, we're going to set the miss approach altitude at 300 feet above this minima. So 300 feet above is 1200 feet. I'll set miss approach altitude 3400 feet. Intention of visual. Here in an RMP, I would say what my contingencies will be. In this case, I'm going to fly the LS, straight in LS runway 32. What if the LS is in up? Maybe the RMP. Possibly an approach with another runway with a circling for the runway 32. We got plenty of option. Worst case for the RMP is what happens if in IMC I lose contact at the minima. So I lose my FMC at the minima here. What am I going to do? So I want to fly away from the mountain, for example, and I want to make a right turn towards an Avades Carbonara, which is somewhere around here. Of course, that has to be coordinated if that happens, but that's a worst case scenario for an RMP approach. Hopefully it will never happen. Landing gate, finally, it's 500 feet. So before we skip this part, I will also demonstrate something about the top of descent. As you can see now, the top of descent is 14 miles from our position. Now, I want to increase the speed. Let's see what happens to the top of descent. I'm going to put 280 knots. So now it's 13 miles. Top of descent, when I increase the speed, as you can see, moved up here and now it's 29 miles. So there's a big difference, 60 miles. Now let's put 320 knots. Now it's at 28. We put it at 320. Now the top of the descent is moved way up here, and it's 40 miles out. So as you can see, the top of descent is a function of the speed, because the higher the speed, the steeper will be the gradient of descent. Now I'm going to go back to Econ, and now we're going to see popping up again the top of descent around here. So it's 7 miles to the top of descent. Let's say that ATC, like in the other video, is going to keep us high again. We got reset MCP altitude, we know that, but ATC tells us stand by 1 minute due to traffic below. There is a traffic passing by here. So what can we already anticipate at this stage? 1,300 feet high, ATC tells me, okay, you can descend to level 190. You're number 2. So we set 190. My first action, as I showed you the last video, we go level change, and then we assess the situation. 245 is not going to be enough to recover the path, so we can try with, let's try 270 knots. That's a bit too much. 260 knots. And of course, when we put it in the FMC, we also put it in the MCP. As you can see now, we have an acquired rate. I have everything out, as I showed you in the last video. As soon as I press VNAV, it goes back to VNAV path, and it's catching the path. We're back again now in the cruise, 170. ATC now tells us fly direct to Carbonara and descend to level 110. So we set 110, as we showed yesterday. We'll press level change before the pilot monitoring executes the point. We execute, the thrust lever will close, and we're descending. Are we going to keep the same speed? As we said yesterday, we can increase the speed. We'll try 265, but I only have around 6,700 feet to 100 and 5,700 feet to level 110. So yes, we can accelerate. Of course, I'm not going to accelerate way too much. We can put 270 just to recover this path. We'll put 270, and if we see that we're not acquiring this path, we can also think of using the speed brake. Now, as we're descending, go back to VNAV, it's on VNAV speed, the airplane will pitch for 270 knots, and once we are on the path, it will automatically revert to VNAV path. As you can see, it should work out. Otherwise, you can use a bit of speed brake just for 300 feet. So shortly, VNAV speed will revert to VNAV path. There you go. So as soon as it does, slowly store the speed brake. And happy days again. Now we simulate again a descent to 6,000 feet on the QNH 1023. We do the call out and we fly direct to EPIDA. So EPIDA, as you can see, it's right here. EPIDA is here. So what is this? This is a shortcut. So if this is a shortcut, this path is not going to be correct anymore. So if we get that direct, in the meantime, pilot monitoring will put EPIDA on top, is going to read back to the ATC. You'll press level change. You're going to deploy the speed brake. You call execute. and now we are 3,200 feet above the path, basically. I'm going to exaggerate this. This is not going to happen in real life, but this was just to show you the anticipation that you can do as pilot flying. Because as I said on the other video, every second counts when dealing with the high energy management. We have to remember that we have to maintain 250 below 100, so we're going to insert 250 knots here. And then we assess the situation again. Flight level 100, as we saw in the other video, we need to have 35 miles to touchdown. That's 10 by 3, 30, plus 5 to decelerate, plus the wind, so 36 miles. Now we'll check at 10,000 feet how many miles we have. So it is now 10,000 feet, and we have 30. So we're 6 miles high, so pretty much 2,000 feet high. And this pretty much reflects what we have here. Next gate, 9,000 feet, by 3 is 27, plus 5 to decelerate 32, plus 1, 33. I need to see 33 here. I have 27, so 6 miles, still 2,000 feet high, and still reflects this. Now let's do the last check, 8,000 feet. So 8,000, we said 8 by 3, 24, and I teach you a little trick here. That's what I do, that's why I always have this. It's just a quick calculation, you see. Remove this, that's 24, plus 5, 29, 30, 25. Now we're only 5 miles high, so slightly less, around 1,700 feet. And it reflects perfectly, 1,700 feet. Next is going to be at 7,000 feet. 7,000 feet is going to be 21, and 5, 26, 27, 22, still 5 miles, so around 1,500 feet, between 1,500 and 1,700, and this reflects. Now we're going to get a lower altitude. By TC, we're going to get, let's say, 4,000 feet. So 6,000, 18 by 323, 24, we have 20, we're only 4 miles high now, it's 1,200 feet. Perfect. VNAV is indicating correctly. But now we've got a decel. So remember, guys, we're in level change. So we have to decelerate. And as we said on the double brief, we were going to be 220 Carbonara and 185 by Epida. So we have to slow down. We slow down the aircraft. And then we start configure. So flaps 1 and flaps 5. The aircraft will start turning. Still 900 feet high. 5,000 feet, we need to have 15. Nothing here to decelerate. We've got 15. So we're getting on path. I'll put the runway heading 315. And I can put also flaps 10. So we're clear for the approach. We can select the next altitude. We check it in the FMC. We briefed it before. We're going to put 2,800 feet. It's set in the MCP. And now we're slowly getting back on the path. We can go back to VNAV. So we can match the speed back to flaps 10 speed. This is the correct page that we will have. Now we're going to put the next altitude, 2,100 feet in the MCP. And I can also stow the speed brake. We got the speed, we want it to be 180 knots, we are below 180 knots. As we said, the next call out will be done by the pilot monitoring, 2 miles before the Fox Delta 32. It's going to be approaching descent. And the FAF call will be done by the mileage, not by the ND, by the mileage, so 7 miles. Remember the descent point, we can mention where we want it, while the FAF is based on a nav aids. So it's going to be 7 miles from Cagliari VR.
Approaching descent.
Okay, so I'm going to put 900 set, VNAV path, speed intervent. Of course, everything has to be checked here in the FMA. So this is the FAF, 2080 feet, no flags. So at 1200 feet, we're going to set the missile approach altitude, gear down, flaps 15. So now it's 1200 feet. I'm going to set the missile approach altitude. I'll check on the FMC of the pilot monitoring, and I will set 3,500 feet here.